Hello everybody. So here we have a problem that we can solve utilizing trigonometric principles and ratios. So in general in mathematics, to solve word problems such as these, it's actually very helpful if we have a visual representation of it. By having a visual it's helpful in understanding the problem and seeing how to go about solving it. So what do we have? We have a building and we have 2 points on the ground and we have certain angles that are made between those points and the top of the building. So let's see how we can draw this out. It says that we have a point A on the ground to the angle of elevation made to the top of the tall building is 24.1 degrees. So the first order of business is to see if we can draw it out. So let's draw this building, and this dashed line will represent the ground, and we have a point A that makes an angle of elevation to the top of the building, and this angle is 24.1 degrees. And in the second sentence it says we have a point B which is 600 feet closer to the building. So if this is point A, point B will be somewhere closer to the building, and it's 600 feet closer than A is. And the angle made between B and the top of the building is 30.2 degrees. So far, this is what we have. Let me just make this a little better. Okay. So this is what we have now. The next thing we can assume is that this building and the ground makes a right triangle. Great. And I mean, it makes a right angle, making right triangles. So this is one right triangle, and this is another larger right triangle. And we're going to use these two right triangles to our advantage. So we're able to describe the visual of the problem. Now, the second order of business, the second general tip that we utilize to solve word problems such as these is to define our variables. So the first thing we want to do is to draw a problem. And the second thing is define variables. So define the things that we don't know. And this is where algebra comes into play. So what is it that we're looking for? It's the height of the building. And so we can call this H for the height. So this is the height of the building. And this is what my goal is, to figure what this thing is. So far I've defined my variable here, H. Now, at the current state that we're at, we have a side. It's unknown, but we called it H. We have an angle. But in order to utilize these trig functions, we need to have something else. We need to have another side. So let's try to study this problem a little bit more. We have a right triangle here, small one, and we have a larger one here. And in both of these triangles, we have a common H that's unknown. Also, if you pay attention here, this side here appears in both of these right triangles. So we could use this guy and call it X. Now this is like the little step that we have to make. We have to call this a new variable and we call it X. And the reason why that's helpful is now I can apply these trig functions. Looking at this smaller triangle, look what we can do. How can we now relate the variables together? So we can relate them by seeing what the angle is and how the angle is related to these sides. So this angle here is opposite H and adjacent to X. So opposite over adjacent, we use tangent. Tangent of 30.2 degrees equals the opposite side, which is H, and the adjacent side, which is X. So this is my first equation. And this comes from smaller right triangle. So now look what we have. We're applying these trig ratios to solve. But at the moment, we only have one equation, but we have two unknowns. So I'll need to have another equation. And this other equation comes from the larger right triangle. And if we look at the larger right triangle, we have the angle 24.1. And we're going to utilize tangent again because tangent of 24.1 is opposite h, and it's adjacent to this side here, because remember, we're looking at the right triangle, the larger one. So the side that's adjacent to 24.1 is 600 plus x. So now I can set this up as 24, tangent of 24.1 is equal to the opposite side, which is h, divided by the adjacent side, which is 600 plus x. This is my second equation, and this is from the larger right triangle. So now we have two equations and two unknowns. Great. Now we have two equations and two unknowns. How do we solve for the variables? We can solve by substitution. So look at the first equation. I want to solve for one of the variables, and the simpler one to solve for is h. So solve for h in equation 1. So in other words, I want to get h by itself. So let me write the equation again, and I get tangent of 30.2 degrees equals h over x. So in order to get h by itself, I got to multiply x on both sides. So the x's cancel, and I'm left with h, and this becomes x times tangent of 30.2 degrees. So look what I have. Now I have h in terms of x. So h is in terms of x. Now why is this helpful? Well, now I solve for one of the variables from the first equation, and this variable h appears again in the second equation. So now I can substitute in the expression for h that I solved in equation 1 into the second equation. So now I can substitute h in equation 2. So look at equation 2, and I got tangent of 24.1 degrees equals h. But h from equation 1 is x times tangent of 30.2 degrees. So now I'm going to replace h with this expression in terms of x. And then the question is, why is this helpful? Well, now look what happens. I have an equation with only one unknown, which is x, and I can solve for it. So all of this stuff, after this step here, everything here is algebra. Now, how to get x by itself? Well, first I got to get x on the same side. I want to isolate x. So the first order of business is to multiply by 600 plus x on both sides. Now the 600 plus x here cancels. The denominators on the right side cancel the denominator here. So I'm left with x times tangent of 30.2 degrees. And this will equal, now here you see I have 600 plus x multiplied by tangent of 24.1. So I can distribute the tangent to everything inside here of the parentheses, so to get rid of it. So I get 600 times tangent of 24.1 degrees plus x times tangent of 24.1 degrees. So now after I distributed the tangent, I have these parentheses are gone. And now what's the goal here? I want to get x, right? So now I can subtract x tangent of 24.1 on both sides. And if you notice, I haven't actually plugged in anything into my calculator yet. I've left everything in its exact form. So I'm going to use my calculator at the end. So it's a good practice to keep everything the way it is intact. So this is what I have at the moment. And I have all the x's on the right side. But I still want to get x by itself. So I realize that x now is a common factor among these two terms. So I can factor out the x. And I'm left with tangent of 30.2 degrees minus tangent of 24.1 degrees. This equals 600 times tangent of 24.1 degrees. But I want to get x by itself. So I need to divide both sides by tangent of 30.2 degrees minus tangent of 24.1 degrees. On both sides. I need to divide it on both sides. So now this is what I have. And now these tangents here are gone, are canceled out. And I'm left with that x equals 600 tangent of 24.1 degrees over tangent of 30.2 minus tangent of 24.1 degrees. So in effect, I've solved for x. It's this whole expression here. Now, this is when I need to utilize the calculator to find what that x value is numerically. So just be careful that when you plug this in to your calculator. So we're going to plug in this fraction here. So I'm going to put the numerator, and it's utilizing parentheses. So my first set of parentheses, I'm going to put the numerator, which is 600, tangent of 24.1 degrees. Now make sure, because these are in degrees, that your mode on your calculator is also in degrees, and it is. So we can proceed. So I have 600 tangent 24.1 degrees divided by, and make sure you put parentheses around your denominator. This is extremely important. Put parentheses around everything. So I'm going to put parentheses around the tangent of 30.2 minus the tangent of 24.1. And when I do so, I get 1992.638095, and this is an approximation, of course. But so now look what we have. We have x, right? But did we actually solve the problem yet? Well, we haven't. What's the problem that we're looking for? We're looking for the height of the building. We're looking for h. But we found x, which is good because we know what h is. H is what? X, whatever x is, times tangent of 30.2. But I found x. So once I find x, I need to find h. And now h is defined as tangent, or I should say x. But my x value is what I found already. So this should be 1992.638095. And I need to multiply this by tangent of 30.2 degrees. So now I'm going to multiply my x value, which is the answer here, by tangent of 30.2. And when I do so, I get h is 1159.743065. And if you round this to the nearest whole number, you get that this is 1160 feet. So my height of the building is approximately 1,160 feet.